Perception and Sensation, Chapter 4, pages 110 to 119. It is section 4 of the reading. So to begin, the section is titled From Metaphor to Formal Model. So to describe the first approach is the Bayesian or Bayesian approach, and that's basically formalizing the idea of our perception as a combination of current stimulus and the knowledge about the condition as well as your observation. So the three parts of the equation is probability, particular state, and particular observation. And for example, if you were to observe a letter, and the left half looks like an E, and the right half looks like a 3, and then you put them together thinking that the E makes a C, or that the 3 made a B, but ultimately it looks like a B. I can show you here. Right there. See it? It's hard to explain, but once you see it, it's much more easy to conceptualize. So then we move on to object recognition, and that's basically in the temporal lobe. So V1 is lines and edges, and V2 of the temporal lobe is early local features of an object. Then V4 is no perfect set of stimuli to really explain that. So then it gets more complicated as far as you go in, and stimuli are different regions of the cortex light up. So there's a subtraction method. So that's the functional magnetic imaging of the brain activity measured in two conditions, one with the use and one without the use of the object, and basically it is subtracting the second stimuli and the regions of the brain, specifically by person. And then it involves the parahippocampal place area, the PPA, and that's the region of the extrae visual cortex in humans, specifically and reliably conceptualizing the image, as well as there's the fusiform face area, FFA, a region of the extrae visual cortex, and that is specially and reliably activated by the human face. And then we have the extrae body area, EBA, and that's a region of the extrae visual cortex in humans, but is special and reliable activated by images of the body or basically other than the face. So then the next section is template versus structural descriptions, and the naive template theory is a visual system recognizes object by matching neural representation of an image with a stored representation of the shape in the brain. There's the structural description, that's a description of an object in terms of the nature of its constituent parents and relationships between these parts. So in the structural description, there's geons, G-E-O-N-S, and that's the geometric ions that Biedman recognizes by components of a model, geometric ions out of which perceptual objects are built. Also in the structural description is recognition by component model, the Biedman's model of object recognition, which holds that the objects are recognized by the identities of the relationships of their component parts. And then there is viewpoint and variance section. So, one moment. So that section includes a property of an object that does not change when the observer and the viewpoint changes, and then also a class of these theories in object recognition that proposes the representation of objects do not change when the viewpoint changes. There's problems with the structural description theory, such as out of viewpoint dependent versus viewpoint dependent, and then moving on to multiple recognition committees. So these are at the entry level category. The first broad, second is specific, and then the third is superordinate. For example, the first broad would be a picture, You could identify it as a bird. The second is specific, so you say eagle. And then the third is kind of more general, so you're saying it was an animal. So then the subordinate is specific, and the superordinate is general. And then faces and illustrative special is the next section, in which faces are very special, and when you don't have the ability to recognize faces, it's called prosopagnosia. Double disassociation is one or two functions, such as hearing and sight, can be damaged without harm to the other one, or vice versa. Then there's congenital prosopagnosia, which is the non-recognition of faces, and that's by birth, and that's not a head injury. And then a small section right at the end is the pathway runs in both direction feedback and reentrant processing. So that is a different theory as a whole, talking about object recognition. And so basically we've been talking about the normal down what V1 pathway, but it's not a one-way street. It's more like an up and down, and it gets bigger and bigger as it gets in the brain. And the re-entry basically is a block consciousness awareness, and once you see an object and you give it attention, it changes kind of how you perceive it in the brain. So that's where it's a little bit different. Re-entrance, so you see it, you think about it, you kind of re-enters your brain again in a different neural pathway. So it's very interesting. So that was that section.